We are going to practice adding in base 6. Our example is going to be 453 base 6, 453 base 6, plus 205 base 6, 205 base 6. We're going to practice this addition using base pieces, a place value chart, and an intermediate shorthand. And remember that our job as teachers is to help students progress from using concrete objects like base pieces to using shorthand, like we'll use an intermediate algorithm, but heading toward the standard algorithm. I want you to notice over here that the largest number I have is 5. Our digits in base 6 are 0, 1, 2, 3, 4, 5, because when we get to 6, we create a group. We group them together and move them to the next place value over. Okay, so I have our base pieces set up here. I have 4, 4, 5, 3. Keeping in mind that our positions are 3 in the ones place. I'm in base 6, so 3 is in the ones place, 5 is in the longs place, 4 is in the flats place, and same thing down here, 5 is in the ones place. I have 0 longs and 2 flats. So I have 4 flats, 5 longs, and 3 ones. In base 6, you can see there are, each long has 6 ones in it, and each flat has 36 ones in it. Okay, so we are ready to add. I am looking to create groups of 6. I'll start in the ones place, and I guess I'll group these 6 together. That creates a long. So I will glue those together to create a new long. So I've exchanged the 6 ones for 1 long. That leaves me with 2 ones over here. And now I'm looking for a group of 6 in the longs place. I'm going to take these 5 plus this 1. That creates a group of 6 longs. And 6 longs grouped together creates 1 flat. Notice that I have no longs left in my longs place. 2 ones, no longs. And now I'm moving on to the flats place, and I am looking for a group of 6. I guess I'll take these 6. And that creates a cube. That creates a cube. Those 6, that group of 6 flats creates 1 cube. So I have exchanged 6 flats for 1 cube, which I can actually replace with a pre-prepared cube if you prefer that. And then I can actually replace that with a pre-prepared flat. Okay, so my final answer should be 1 cube, 1 flat, 0 longs, and 2 ones. 1, 1, 0, 2, base 6. 1, 1, 0, 2, base 6. So now let's progress along in our thinking here. So that was using base pieces, and we got the answer 1, 1, 0, 2, base 6. Now let's see what happens when we use a place value chart. So again, we are in base 6. As with all bases, the rightmost position is 1. Since I'm in base 6, the next position over is a 6. The position to the left of that is 6 squared. The position to the left of that is 6 cubed. If you prefer to think in terms of 1, 6, 36, and whatever 6 cubed is, you are welcome to do that. It doesn't, as long as that, that base 10 notation that I have up above here doesn't confuse you, you are welcome to think in those terms. Okay, so we are starting with 4, 5, 3. I'm going to write my little subscript base 6 out here. It's out of the way, but reminding me that I'm in base 6. And then I'm adding to that 205 base 6. I am adding. And I'm going to use exactly the same process that we did with the base pieces, but now I'm using this, these symbols instead of the physical concrete objects. Okay, so 3 plus 5 is 8. Remember, I had those 8 little ones there. I'll write the 8, but I know I can't leave 8 because 8 is not a valid base 6 number because it has a group of 6 in it. So let me decompose that into 6 plus 2. And I used 6 because I'm in base 6, so I'm looking for groups of 6. These 6 ones I will exchange for 1 long. So I'm moving those 6 ones, I'm exchanging those 6 ones for 1 long. That leaves me with 2 ones. I'm going to go ahead and write this 2 here just so I don't lose track of how many ones I had there. And then I'll move to the longs column. 5 plus 0 is 5, plus the 1 that came from exchanging the 6 ones. So this gives me 6 longs. And again, I'm looking for groups of 6. If you want to, you can think of this as 6 plus 0, if that helps you be when you're that explicit. I will exchange 6 longs for 1 flat. Remember, we did this with our base pieces as well. So I've exchanged 6 longs for 1 flat. That leaves me with 0 longs. Remember again, when we did the base pieces, I ended up with 0 longs left once I had done that exchange. Now moving to the flats column, I have that 1 from exchanging the 6 longs, and then what was already here was 4 flats plus 2 flats, gave me 6 flats, plus that 1 that came from doing that exchange, gives me a total of 7. Again, I can't have 7 because that has a group of 6 in it, so will write that as 6 plus 1, and then I will exchange those 6 flats for 1 cube. Those 6 flats get exchanged for 1 cube. I have 1 flat left in the flats column and my 1 cube that I created from exchanging those 6 flats. So again, my answer is 1102 base 6. And we should get the same answer, and we should be able to see in our place value chart the symbols, the symbolic representation of what we went through with the physical objects that were the base pieces. Okay, let's move on to an intermediate shorthand. This is intermediate because it has less explicit information written down than the place value chart, but more explicit information written down than our shortest shorthand, the standard algorithm that we usually use. So I'm going to set this up like our usual addition, our vertical addition here. So 453 base 6 plus 205 base 6. And again, going through those same thought processes, but this time I'm going to notice that I don't have physical objects like base pieces. I also don't have labels like I do in a place value chart. So I need to know, my students need to know, that this column is the ones column, and this column is the sixes column or the longs column, and this column is the flats column or the 36s column. I'm going to maybe make a note to myself over here that my process should be that I'm going to add the ones, and then I'm going to add the longs, and then I'm going to add the flats, just like I have before, but I'm using a shorthand now. I'm going to also do some scrap work over here. The scrap work I'm going to do is because we are fluent in base 10 basic addition facts, but not in base 6 basic addition facts. So I'm going to need to do some scrap work over here to help me think in base 6. So, for example, 3 plus 5 is 8. We already knew that. We saw in the place value chart that we could write that as 6 plus 2. What that means is that 8 as a base 10 number is the same as 1 group of 6 and 2 ones in base 6. So 8 as a base 10 number is equal to 1, 2, base 6. That's what I'm going to write right here where I said I was adding the ones. When I added those ones, I got a group of 6, 1 group of 6, and 2 ones. 1 group of 6 and 2 ones. Now I'm going to add the longs. 5 plus 0, 5 longs, plus 0 longs. It's 5 longs. So I'm going to write the 5 in the longs column. I'm going to write the 0 in the ones column because I don't have any ones. When I add those longs together, I have 4 plus 2, which is 6. I have 4 plus 2, which is 6. And since I'm in base 10, I know that that creates a group. I want to think carefully about what that group should look like. 6 flats, right? 4 plus 2 equals 6 flats. When I group those flats together, I get 1 cube. So I'm going to exchange 6 flats for 1 cube. That will leave me with no flats. So maybe I'll make a note of that as well. That leaves 0 flats. So let's do that exchange over here. I'm going to write the 1 in the cubes column, a 0 in the flats column. When I was adding those flats, I have 0 longs and 0 ones. And now I'm going to add all of these pieces together. So I end up with 2, let's see, I'm going to keep my subscript here. I end up with 2 ones. I need to think again about doing these exchanges. 1 plus 5 is 6. 1 plus 5 is 6. So we know that this, these 6 longs create a group of 6. Those 6 longs create a group of 6. Let's see, so 6 longs. Let's exchange 6 longs for 1 flat. We're going to exchange 6 longs for 1 flat. That will leave me with 0 longs and 1 flat. This time I did that carrying action that we see in the standard algorithm. 1 plus 0 is 0, 1, and then that 1 is still there. So 1, 1, 0, 2, base 6. 1, 1, 0, 2, base 6 is still our answer. Those exchanges are still there. We saw this. 1, 2 is actually right here in the intermediate algorithm. There's my 1, and there's my 2. That 1, 2 is right there. This 5 is that 5 that's right there. This 5 is that 5 that's right there. This 6, this 4 plus 2 that got me that 6 is this 6 that's here. This 6 that I wrote over here in my scrapbook is this 6 that's right here. I add this 1 to that, and that gets me 1, 1.